Hello and welcome to today's Tech Talk on operationalizing HiGHS-based MIP models and the Q&A with the project developers. My name is Haley. I'm part of the Next Move team and I will be your MC for today. Today's presenters are Ryan O'Neill, CTO at Next Move, Yvette Galabova and Julian Hall, the HiGHS developers based out of the University of Edinburgh. Today's session is going to cover a quick orientation and speedrun demo of operationalizing HiGHS in the Next Move platform, but the bulk of our time is going to be spent on Q&A and discussion with Yvette and Julian. So we encourage you to use the Q&A feature at the bottom of your screen. You can also use the chat off to the side to ask questions and leave comments. Just keep an eye on that host and panelist versus everyone toggle so that your question or comment goes to the right audience. And with that, I'm going to hand it over to Ryan. Take it away.
Thanks, Haley, for the intros, and thank you, Julian and Yvette, for joining us today. All right, so as Haley mentioned, I'm CTO here at NextMove. We're going to give you just a very brief demo to show you how we are using HiGHS. The star of the show here is, of course, the HiGHS project. So if you are not familiar with HiGHS, I'll just give you just a very, very brief intro as to what it is. Yvette and Julian will talk a lot more about this in a bit. But basically, HiGHS is a recent entrant to the open source optimization world. It started being developed around 2018. There's a lot of excitement around HiGHS, both because of its performance as an optimization solver and the speed of the development team and sort of how they're ramping up on new features and things that they're adding to the solver. So we'll show in a demo how we at NextMove are using HiGHS. But quickly, I'll just give you just the lay of the land there. We started using HiGHS to solve sort of large-ish mixed integer programming models through a Go wrapper that we built ourselves. These were for capital budgeting and on the order of like 4 million to 6 million variables, or it's 4 million rows and 6 million columns. That's when we sort of started to get really excited about the performance of the solver and started to build out marketplace apps around HiGHS. So we have in our NextMove marketplace applications for shift scheduling and order fulfillment, both of which use our Go APIs, and then price optimization and facility location apps, which use our Ample integration. Ample has also on their own built out stochastic facility location models in our infrastructure, which use obviously Ample. HiGHS as the backend solver, the NextMove platform, and Streamlit for visualization and user interfaces. What we're really trying to answer with the integration between HiGHS and NextMove is how do we cross the development to production chasm. So NextMove is a decision ops tool for optimization solvers and modeling languages and decision applications. And HiGHS is an open source solver. And so there's sort of an obvious pairing between these two that works really nicely. Frequently, when we are operationalizing an optimization tool, the first step is obviously building the model, right? So we want to build a model that does something like routing or scheduling or maybe bin packing or something like that. And once we've done that, we have a bunch of questions to answer. The first question is, how do we deploy that into a production environment? So how do I get it from my machine into an environment where it's running to serve users? And those could be, apps that are on people's phones or computers. They could be actual operators who are using a visualization around the model. How does it go from my machine in some sort of usually a Git-based flow into these production environments? We also have to figure out how we're going to test it. And this is a fairly thorny issue. It could be things like how do we unit test a model, which by itself is not necessarily very simple. It's also questions like how do we integration test optimization with other services? And then how do we make sure that the model itself is able to both scale horizontally and to larger instances as our business and operations scale? So maybe we have more drivers, more shifts that we need to schedule, and we're operating, say, in more regions. Does the optimization model and solver that we have scale up to meet those demands? We also have to be able to test and understand the impact of change on our operations. And this is really coming from two sources. One is the business and the operations itself. We frequently need to represent changes to the online or on the ground environment in our model and make sure that our KPIs aren't degrading. and are staying where we want them to. And then we also frequently need to update that model over time to account for changes in the environment or to account for how we want to further push our model to give us better results. And so testing constraint changes and input changes and environmental model drift is also a very important part of testing optimization models, which may not be present in other systems. We also want to be able to integrate our optimization model with CI/CD, do checks and versioning and sort of all the software things that you need to do to roll out new versions and manage versions and rollback. And then finally, we need to establish buy-in from stakeholders. And these could be people in on-the-ground operations. They could be P&L people working in the business side of things. It could be product managers, so on and so forth. All right, so we'll do a very, very fast speed run, and then we'll get into Q&A with the HiGHS team. So as I mentioned, we have a number of marketplace apps that we've already built, and we're sort of building out some more of these with HiGHS. And so you can see these in the Next Move marketplace. We have HiGHS shift scheduling and order fulfillment, both of which are built using direct Go integrations to the HiGHS library. And then we have ample price optimization and facility location, which are built through our ample integration. Today, we're going to look at the ample price optimization model. So if I go into that, I see something like this, which is essentially the model details. And what this model is essentially doing is telling me how many of units of some good to ship to different regions, what to price them at given a relationship between price and demand elasticity, and sort of how to maximize profit given expected waste and sales, right? And so, once I clone the app in my space, I get essentially an API reference, and I can run it. If I click on Run App, I can load a sample input, which has things like which regions to ship goods to, what's the total amount of supply, what are my transportation costs, more on that in a minute, and what are minimum and maximum product allocations, and so on and so forth. And then a regression, a description of a regression describing that price demand elasticity curve. Okay. So what I'd like to do is study the impact of transportation, uncertainty in transportation cost as it pertains to outputs of the model. So we're going to create a new experiment, and I'll just call this batch experiment 1. And then I'm going to select a set of input files. And these are input files that I've essentially created to run through this model, which have perturbed transportation costs. So if you remember just a second ago, we showed this vector of transportation costs to different regions of the goods. And this essentially just changes that. And so what I'm going to do is select those 20 inputs, and we're going to run this same instance of this model, which is essentially a versioned tag of that HiGHS model under the covers. And we're going to create this batch experiment. Once I do that, it immediately starts running, and I can see that it's queuing up runs and doing sort of all the orchestration that's required in order to get these optimization runs going through the infrastructure, collect the results, so on and so forth. I'm going to go back to here and click on the experiment that I did right before this, and we can see those results sort of aggregated in this experiment view. So I'm grouping them by instance ID and version ID. And what this is essentially showing me is that given all these random inputs, what can I sort of expect on my objective value from these different transportation costs? And so I have sort of a range on this, which helps me get my head around the uncertainty here. And I can also answer questions like, what is the impact of these transportation costs on price and demand and sales in different regions? So for example, here I can see that the Great Lakes region is somewhat dependent on transportation costs, i.e. the demand in the Great Lakes region. But for example, for this model, the Mid-South might not be. And so I just sort of have this flat blocks plot there. All right, so that's the demo that I was going to show. All of these models that we pointed out are using HiGHS as the optimization solver under the back end. And what NextMove is essentially providing here is integrations around it to do the decision ops flow. I'm going to go back to the slides now. So briefly, we just reviewed the HiGHS-based model for price optimization and showed it in a workflow where we were running a bunch of different optimizations at the same time to study what happens in different transportation costs and handle uncertainty. To do that, we ran an experiment, and we essentially operationalized a HiGHS-based model very quickly within this infrastructure. let's go over to Q&A now. So Yvette and Julian, I shared some high-level information about the HiGHS project earlier. To get us warmed up, can you give everyone a brief orientation to the timeline from essentially from inception to now of the HiGHS project so far?
Sure. There's a bit of prehistory in that at Edinburgh we had a couple of really high quality linear programming solvers written by PhD students who left them to us after they graduated, but we couldn't exploit them because they were written in C++ until Yvette came along and could kind of bridge the gap between me and these codes, and she contributed to them. And for a while it was just a couple of good LP solvers until I saw there was a real gap in the open source market due to aging projects elsewhere. And we decided to actually turn them into proper software. And well, there's a lot. There's an awful lot I could say, but the game changer was when we managed to get our friend Leona Gottwald to write a MIP solver for us, which was a win-win because she really wanted to do it, and that's really changed everything. And since then, we've been looking still to improve and broaden what we offer alongside those solvers. And yeah, that's pretty much where we got today.
So I remember from the HiGHS workshop, you all just hosted this back in June, but you had an opening talk, which was essentially from gradware to software, which was, I think I thought a great name for that. So you all just hosted this first HiGHS workshop last month. A bunch of people presented how they were using it in the wild. What are some of the applications that stuck out to you?
Okay, there were quite a few. We were very pleased with how the workshop turned out. It was a first, so we didn't really know what to expect, but we got a lot more industrial participants. We got a few academic and a few students, but from the industry, there were varied applications. One company that made an impression on me is a Dutch company that optimizes water flow management, and they have several objectives. The most important of which is not to flood the Netherlands, how they should open and close the gates of the channels so it all works out. And a recent objective they incorporated is to look after the fish better. They have investigated the impact of water pumping on the fish migration and well-being, so that was a really nice application. And another one that made an impression is from a Danish company called EMD. They make software for energy modeling, and power plants, particularly producing renewable energies, use their software to model and optimize their production and also trading prices. So these were really interesting. And from the academic participants, there was a really interesting talk on the kidney exchange program in the UK. So someone is modeling that as a problem, and at the bottom using HiGHS to solve the allocation of organs to people in need of surgery. So that was really great, I thought, as well. Julian, would you add another application?
Yeah, I mean these digital twins really do appeal to me because I like the way that you can actually see directly how the software is being used. I was quite impressed that we had very large companies using HiGHS. For example, Microsoft Research. You tend to assume that they would use commercial software, but I can see that we've got it's good to see that we've got a corner where it's more convenient to use us, and we're powerful enough for them. Yeah, of course, we're also very impressed with NextMove.
As a participant, I really liked the structure that you had, combining all the industrial and academic applications. I thought that was really nice and refreshing. So if I can put my vote in for next year, it'll be similar. So question about open source. open source is frequently a springboard for newcomers to a discipline. I think we're seeing a lot of this in the people in the data science world adopting optimization tools are reaching for open source initially because that's what they're used to. In optimization and operations research, there's a lot less open source software than there is in like machine learning or data science. How do you view the role of open source in OR and optimization today? And how do you think that will change in the future?
Basically, OR's not probably quite as amenable to open source, because particularly when you come to solvers, they are they are phenomenally well developed technical things, which are very hard for someone to just produce in a short time. But the good thing about the technologies which are available to support open source, like things like GitHub and CMake, is that if someone does come up with something new, then they can popularize it fairly easily. And we've seen a good example of that with this third way of solving LP problems, known as PDLP, which is, there's a lot of excitement around that at the moment. And I also see an increased role for open source optimization, simply because the world is getting increasingly open to the use of open source software, and that hopefully in the future we'll see the funders realize, the philanthropic funders realize that supporting this is important.
Yeah, I remember from the talk you gave on this, I was completely unaware before that there was a new way, more efficient way of solving LPs, which was a little bit mind-blowing given all this time.
Yeah, it's also driven by the availability of GPUs, because it's not very efficient on CPUs. But it was clear, because we were at ISMP last week in Montreal, that people really are grabbing hold of the increasing capabilities of GPUs. They can't and what they can do, and that is changing the way that we might solve even LPs, and which is opening up new routes for people to contribute.
Yeah, I think one of the things that we're learning from sort of the recent AI revolution is that a lot of people are willing to use customized hardware for something like this, something specialized like this. It doesn't all have to necessarily be commodity hardware, which is kind of neat. I have a question from the audience that I'd like to ask, which is, are you planning to integrate generic column generation algorithms into HiGHS? Things like branch and price. What do you have support for now, and what are you planning to add?
We got no support at the moment. I've spoken to people, and we have an industrial collaborator who's interested in putting into decomposition algorithms to HiGHS. We're currently, I think it will happen in some form. We're trying to decide whether it should be an application that sits on top of HiGHS, so therefore it's people who don't need it don't have to drag it around, and we don't have to compile it in order to work on HiGHS. And it might also mean that it can be it's easier for the really smart developers to tailor it to their application. So yeah, column generation, branch and price, Bender's decomposition, they're all in discussion at the moment. Yeah.
All right, so let's talk a little bit about more about open source. From a sort of community and longevity perspective, open source projects are often created by individuals or small groups of people. And then when they take off, they get sort of adopted by larger communities around them. How do you think about project longevity for HiGHS and staying power for the software sort of outlasting the contributions of the initial team?
Well, in optimization, my impression is that it has been an issue. As Julian mentioned, the codes are more complicated, and it's difficult for many people to work on one project. They're very tightly integrated in between. That is the difference with some machine learning open source projects, where in machine learning it's easier to make small modifications and experiment with results and get actually some performance out. And it's much easier to have a lot of people contributing also, because machine learning is a really big field at the moment. There's a lot of funding, a lot of students are studying machine learning and AI topics, but optimization and OR, there's fewer people, much fewer students. Academic funding is not so widely available, and one of the problems in developing optimization software is that there are not enough skilled developers, and the commercial companies are outbidding over the people who are available. And with HiGHS, we had an idea to involve younger people from the start who are up to date with some technical tools and would be able to continue the project over time. So I think it's important to keep younger people involved. And is there anything else you'd like to add?
Well, yeah, I think speaking as the older member of the team, I don't. I'm looking at some of the single person projects in optimization. I don't want to be doing this when I'm 70, 75. I want to have handed it over to somebody a lot younger. And even if it means that development doesn't continue, maintenance is so crucial. So that's why it's so important that I make it worth Yvette's while to continue as a member of the team, because ultimately it'd be great if she takes it over when I'm beyond being able to do that.
So we already have a named successor then.
Planned succession, yeah, which is the essential thing in any revolution.
Yeah,
is you plan for the succession. Funding is also important, and so as HiGHS gets more and more used by companies with funds, and also our value to society is viewed by philanthropic funders. It's important to sort of keep them interested and keep funding coming in that way. But that seems to be working quite well in that there's 3 companies now looking to fund industrial PhD studentships, which will bring young people in, and hopefully we can get more philanthropic funding as well to keep the thing going in the background.
That's great. Yeah, I know at the workshop you talked a bit about the near-term to mid-term roadmap for HiGHS, but I suspect many of our attendees aren't familiar with that. Can you talk a little bit about what the new features we can expect from the project are on the roadmap?
Principally, it's in the world of mixed integer programming, where although we have got the best open source MIP solver in the world, there's still a big gap between us and the better commercial solvers. So we will be implementing some things which will improve the performance of the MIP solver for general problems, and also be looking to add more primal heuristics, which will maybe only be valuable for certain classes of problems. But beyond that, that's just performance. There's also features which people need. At the moment, the MIP solver is a bit of a black box, but we realize we need to add lazy constraints for people who are solving things where they can't define all the constraints initially, and also user cuts where people know what cuts are valuable for the sort of things they're modeling, and they want to be able to insert those at the beginning of the elimination tree at the root node. So that's one thing. The other thing is the new interior point solver for solving LPs. Again, what we've got is as good as anybody else has got, but there's still a gap that we're trying to bridge. So that's already been that work's already been started, and hopefully we will have something for people to play with within a year.
Very nice. So for people that want to get involved in somehow or support the project, what are some ways that people in the community can either support HiGHS or become involved, either using it or in other ways?
Well, funding is always appreciated, and little bug fixes in pull requests are also appreciated. We are an open source project and we have had contributions. Major changes to the MIP solver are more questionable at the moment. We're careful not to modify it very much and to make sure everything is thoroughly tested. So for the moment, we'd like to keep its performance and only possibly eventually improve it. I think ideally people can support HIGHS by using it, because the more people use our code, then the more likely it is that we'll continue being able to develop it.
We're also able to take contributions in kind, and a nice example of this is MathWorks. MathWorks now uses HiGHS as its LP and MIP solver, and they have an employee who used to maintain their MIP solver who is using his time, quite a lot of his time, to help improve our MIP solver as well. And so no money changes hands, but it's a kind of a win-win on both sides.
Yeah, that's great. And I know for people who just want to get started using it, you do have extensive documentation on the site, but there's also a Discord that you just launched. Is that linked to on the HiGHS website?
The
I
Discord,
wouldn't
Not yet. So soon to be.
I, I wouldn't go as far as extensive, but we are getting there with the documentation. There is a nice automation that parses our C strings in the C API to the documentation website, and Discord is a very recent addition. We only created it after the workshop because a lot of our users expressed interest in being able to communicate on that platform. So it's not linked to the website yet, but it will be. And there we also have a newsletter which we share every few months or so, and that could be accessed on our website.
I think we have one more audience question with the probably minute and a half we have left. Has parallelization been investigated when it comes to large scale modeling and model solving?
Yeah, I mean that I've had many years trying to parallelize the simplex algorithm with not great success. Because it's damned hard and lots of people have tried, and also the tree exploration in the MIP solver will be parallelized. Beyond that, no, it's hard to parallelize general optimization solvers.
All right. And I think with that, we are at time, unless we want to do one more question. Oh, yeah, there is one more that maybe we should do. Can you discuss the current state and plans for commercial enterprise support beyond community support? Do you have any plans to provide above and beyond what we would get through sort of Discord and forums and GitHub and things like that?
This is something which I kind of anticipated as being scoped for monetizing HiGHS. And to be perfectly honest, nobody amongst users has actually asked for it, and so it seems to be that it's not there isn't the scope that I thought there might be. So we don't plan to offer it, because obviously there's setup cost in offering a higher level of support, and that's actually paid for. But at the moment, I can't see the value in even offering it.
Okay. And I think one more, can incoming masters or students work on the project? It's very interesting. And what are the prerequisites to know before contributing? It seems like it would require strong programming skills, obviously a strong understanding of optimization and optimization algorithms. What else would you recommend people learn before they help by opening a pull request?
If it's students in operational research, then yeah, that pretty much captures it. It's very hard to contribute to the solver code base. Once we've refactored the primal heuristics, it might be that adding primal heuristics is not going to be as hard as it would be at the moment, and that might be something that an MSc student can do. In fact, one did do a couple of years ago with Leona.
All right, and I think we're at time here, Ryan, to be mindful of everybody's the half hour that we promised everyone. So I'm going to actually wrap us up here. and say huge thank yous to Julian and Yvette for taking the time to be here today. We are big fans of your work and the project. Ryan, thank you for moderating today. I'm going to close by just offering up that we have a Getting Started with Decision Ops workshop that's happening in a couple of weeks. It actually walks through using HiGHS shift scheduling decision app that Ryan briefly touched on today, but we did not dive into in depth. So if that's of interest to folks, please feel free to sign up on our website at www.nextmv.io. And again, big thank yous to everybody for being here today and for all the questions. Thank you so much, everybody.